Hello, and welcome to Building Sustainability Podcast. I'm your host, Jeffrey Hart, aka Jeffrey the Natural Builder. Building Sustainability consists of conversations with designers, builders, makers, dreamers, and doers, exploring the wide world of sustainability in the built environment by talking to wonderful people who are doing excellent things. Hello, and welcome to episode 62 of Building Sustainability, this week with John Butler. This is going to be a bit of a speed intro as there was so much excellent information in this episode that I didn't want to edit anything out. So yeah, I'll just cut to the chase. First of all, big thanks to the new patrons of Building Sustainability. That is Christian McKeon. I don't know if Christian was thanked last time, but maybe you've got a double thanks. Kit Jones, who's a great natural builder himself. Aidan has increased his support to get himself a hand-carved wooden spoon. So that's great. And then finally, Beatrice Hislop, a new supporter this month. I mean, as always, I can't really tell you how much your support means. Thank you. There's going to be an episode coming next week, again with John, this time talking more about natural materials and some exciting research he's been involved with regarding straw. I'll do a little bit more of a tiny house update for that, for anyone that's interested. Otherwise, I will be back briefly at the end. Enjoy, John. I had a thoroughly great time chatting and really geeking out. I hope you enjoy it too.
This is the thing I often struggle with, is how to quickly summarize the slightly different strands of what I do. I call myself sustainable building consultant, partly because when I started, I wasn't exactly sure what route I would go down or what would come up. And I thought that kind of covered a number of bases. But what I do is primarily Passivhaus consultant. So looking at people's designs and plans, either for new build or retrofit, and measuring it all up, putting all the numbers into PHPP, and initially sort of seeing what it spits out in terms of headline figures for heating demand and overheating risk, and then sort of seeing what you can tweak where to get it to work better, which is often, I don't know what it often is. It's not necessarily it's not just a matter of kind of putting in more insulation. Usually it works best when you sort of tweak the form of the building slightly or look at the windows. And I get quite geeky about tweaking window sizes and kind of going, what happens if I make that one a bit bigger and that one a bit smaller, or move that one slightly so it's slightly more shaded. And it's all that kind of thing which makes it work better. And I quite enjoy doing that. And also have relatively recently started doing quite a lot of whole life embodied carbon calculations for buildings. And again, new build and retrofit. Mostly houses. Well, one gigantic school, which turned into something of a nightmare just because of the complexity of working out all the different materials that are in a school, and to work out the carbon impact, you have to work out all the different materials.
I bet, yeah. That
are there in the first place. So it's a bit like kind of quantity surveying without being a quantity surveyor, really. Yeah. So there's, in summary, Passivhaus, carbon calculations, advising on kind of retrofit particularly, and what materials you can use to improve the energy efficiency of your house without causing potential moisture problems with it in the future, and also with a view to kind of low carbon materials. I think when I first started, I had to do a couple of projects which definitely didn't fit my kind of approach to the world. They were sort of all PIR, PUR, foam, very high fossil fuel, potentially quite harmful, definitely quite flammable. But I needed to do the work kind of thing, whereas I think now I've got to the point where I could say no to a project like that, or sort of insist that I'm only interested in projects with kind of low carbon materials or relatively low carbon materials, because obviously anything you use or build with has a carbon impact, but it's getting that kind of relative. So that's a not very short answer. to what I do.
So where do you sit in terms of, you were talking about playing with the sizes of the windows, and I can imagine an architect being really annoyed at you for doing that. So are you working with an architect, or are you working for a client, or how's it work?
It's often a slightly muddled combination of the two, I think. I'm usually officially working for the kind of the end client, which might be self-builders, but inevitably practically kind of working with the architect or for the architect. But in reality, it sort of is the same, in that the aim is to get the clients a really good building, basically. And that means not just really energy efficient, although definitely really energy efficient, but really comfortable in terms of thermal comfort and air quality and light. So there is this sort of perception sometimes that Passivhaus is about reducing the number of windows, and what I said kind of almost backs that up, but it's not. It's not about reducing the number of windows, it's about getting rid of windows you don't need. So there's quite often people get carried away with wanting sort of massive walls of glazing or sort of whole kind of barrages of roof windows. And you can get an awful lot of daylight and an awful lot of views out, usually out of a lot less glazing. So it's kind of finding that balance where you get really nice daylight and really nice spaces, but without kind of excessive heat loss. But crucially, particularly in a heating climate, is looking at overheating risk, which is almost always down to glazing. It does increase the more you insulate a house, but not if you've got your windows set up properly. You can then get a really well insulated, I should say building, not house, and get a really well insulated building, but with a sensible amount of glazing that doesn't cause overheating, but does give you lovely views and all of that sort of thing, which is really important because it's a problem with, I live in quite an old house and it's a bit sunken, and the views out the front are kind of the houses directly opposite and the cars going by, and the view out the back is of a bank because it's a bit sunken. So I definitely appreciate through what I'm missing, what people need, basically. So yeah, it's working with the architect and the client and kind of tweaking things and sort of bouncing things backwards and forwards a bit, I guess. There's usually a kind of initial, I write a report, I do the PHP and write a report sort of saying what I think they should do and primarily explaining why I think they should do it, so that there's a good understanding, because the PHPP can spit out lots and lots of numbers.
And what is PHP?
Good question. Sorry.
Yeah, it's all right.
PHPP is Passivhaus Planning Package. It's basically a giant spreadsheet that the Passivhaus Institute developed to assess the energy balance of buildings accurately. So it's very much a kind of physics-based thing. It looks at all the different ways you can gain and lose heat, and tries to balance that, essentially. So you can, in some senses, balance your heat losses by putting in more windows, because that will give you potentially useful solar gain. But then the sort of side effect of that tends to be that you actually end up with more overheating, and you might have lots of solar gain when you don't really need it and not enough when you do. So it's better to just reduce the heat loss completely in the first place and the gains, so that it balances out that way. And I've forgotten what I was saying before that. Yes, PHPP spits out lots of information, so it can be a bit overwhelming. So I try and kind of put it in a format that is understandable.
Yeah.
And I find writing the report sort of helps me figure out what's happening as well. And then from there, it turns into a conversation more where they sort of go, well, how about if we also did this, or if we didn't do that, but did this? And I quite enjoy that bit, because you get to sort of play with things and fiddle around. And
yeah, it's the sort of constrictions and the things that make a project interesting, isn't it? Like my house at the moment, having weight as a major factor in everything I do has just completely turned my entire thinking of how to build on its head. And where I'd just be like, all right, well, we'll just slap a thing up there. It's like, no, that's really heavy. You gotta come up with a different solution. Like, ooh, okay.
Yeah, it makes you think in different ways, doesn't it? Which is can be frustrating and fun, sort of almost simultaneously sometimes.
Yeah. Wasn't there a thing that Brian Eno and Bowie used to do in the studio where they'd take little cards and they'd have different things on them? Like, the only one I can ever remember is destroy everything. But they'd have these different sort of prompts, and then they'd go into the studio and they'd play the music using this prompt as like an idea
excellent.
to sort of shake up their thinking.
I like that. I think George Harrison did sort of something similar with some of his songs, where he'd just have a phrase out of a book or written on a box or something, and that would become the basis of the songs. I think Little Brown Shoe and While My Guitar Gently Weeps all started that way, but definitely Handle With Care by the Travelling Wilburys, that started from a box with Handle With Care. It's like,
brilliant.
What do we write about? Handle with care. Let's make a song. And I like that. And it is that thing of sort of having restrictions gives you sort of weirdly room to be creative, I think.
Yeah. Yeah. It definitely makes you be creative. Like you have to be more open to different options.
And it makes you, develop things you might not otherwise have done. And that's, I mean, you need to avoid reinventing the wheel, I guess, which is where that could go down. But I think it's mostly more helpful than that.
Yes. The other end of the spectrum is, do what I always do in the order that I always do it. Spit out the same result.
Yeah. So it breaks you out of that, I think, having restrictions. And every project has different restrictions, much as they might be within the same kind of overarching Passivhaus or retrofit or whatever framework. There's always something that you've not figured out before or not had to deal with before on any project that has some oddity. And that's really interesting.
I mean, just, compass location. What do you call that? That's terrible.
Orientation.
Thank you. Oh goodness. I mean, every house is going to have a slightly different orientation. So even if you're building the exact same house, it's going to need to be different, isn't it? Yeah.
And elevation makes a difference. The amount of shading, where you are in the country, it all affects everything. I think what works about the Passivhaus approach, regardless of whether you're aiming for Passivhaus, just the way of calculating the energy balance, is that it's inherently holistic. You have to look at everything and it accounts for everything, which I guess makes it sort of suitable to slightly geekish minds, or at least makes the calculation side of things suitable for slightly geekish minds, because you have to put everything in whether you want to or not. But that then makes it a really holistic approach, and you can't just there's no single solution to anything, which I really like. You have to look at the balance. It is very much about balance, not in a Zen-like way, but just in a practical way, or perhaps in a Zen-like way. It doesn't feel very Zen-like sometimes.
Yeah, I don't know if I've ever thought of Passivhaus as in any way Zen-like.
No,
but
I think when you're in one, it probably is, because it tends to be quite quiet, because you've got the really good insulation and the really good airtightness, which can reduce outside noise until you want it, and then you just open the window, and then you have that outside sound coming in.
Yeah.
But yeah, they can be really quiet and calm places. I think it would depend on your design and your lifestyle and how much clutter you generate for yourself. Obviously, the building won't remove that, he says, looking around. Going, you can't see most of the clutter, actually, because it's mostly in front of me and you're looking the other way.
It looks quite respectful this way.
It's great that cameras don't show the desk immediately in front of them.
Yeah, you just tidy up by pushing everything around. So, I mean, I was going to talk about Passivhaus later, but I think while we're kind of on it, we should explore that, being that you've said it's sort of a large part of what you're doing. So, like, what are the key elements? I always never know what sort of level to pitch this at, but we sort of go for a very brief, low level entry, and then we'll nail into some like really geeky details.
Excellent.
And leave everyone stranded.
Yeah, we'll go off and have a really geeky fun time. I kind of caveat all of this with that there are much more experienced people than me. I'm relatively new to this. I've only been doing it for few years now. But anyway, the basics are a really well insulated thermal envelope. Thermal envelope basically meaning all the outside bits of your building, all the bits that stop outside being inside and vice versa. So really well insulated, very airtight, which is probably a better word is non-drafty. You remove all the places that drafts would get in or that air would come through kind of little cracks in buildings. So it's not about having a hermetically sealed thing. It's just about controlling where the air does come in. So insulated, airtight, and well ventilated, I would say.
Is that's the control of the
where
the air comes in, isn't it?
Yeah. So commonly, always you would use an MVHR, which is mechanical ventilation with heat recovery. They all have such snappy names.
It's science, not like art, isn't it?
But the whole thing with heat recovery ventilation is you get constant fresh air brought into the building and constant extraction of kind of moist air or CO2 that builds up as you breathe, or any other sort of, smells that you get in a building. They're all constantly extracted, and the two paths of air never actually meet. They're kept completely separate, but they go through a heat exchanger so that the heat from the extracted air is passed to the incoming supply air. So you get constant fresh air without losing lots of heat. And it's very low wattage fans that drive this thing. So it uses very little energy. And so the idea is it recovers, the proven physics of it is it recovers a lot more energy than it uses.
Okay. So you're not using you're not pumping all the energy outside of your house with a big fan and then putting the heating on because it's cold.
Yeah. So the sort of standard building regs approach would be basically have holes in your window frames in the form of trickle vents. You've got an extract fan in your kitchen and bathroom that just sucks air out of them and draws colder air in through all your trickle vents, which means you're constantly losing heat and constantly also got drafts because that air coming in through the trickle vent is going to be cold in the winter and it's crossing through your house, so it's inherently creating a drafty situation almost by design, whereas the Passivhaus approach removes that by having this controlled ventilation and making sure it's at a comfortable temperature. And it's also filtered, so there's a lot of evidence now that the air quality internally is a lot higher with mechanically ventilated houses or with MVHR compared to just opening windows, even if you're someone who opens your windows sort of quite a lot, and that varies an awful lot how much people really do open their windows. It just isn't as effective unless you sort of live in a really, really windy place and there's constant cross ventilation. Well, perhaps not really, really windy, but a quite windy place and there's constant effective cross ventilation. And perhaps even then, it's just not as thorough at changing the air in your house. And also it tends to pick up more contaminants through this airtightness thing. It's not just about the energy efficiency of not losing hot air through cracks in your building. It's again about air quality, because any air that sort of comes through the sort of nook and cranny and where things haven't quite fitted together properly in the building, or where a cable comes in or a pipe comes in and it's not sealed around it, will pick up anything that's in that crack or that sort of cable route. And they're not often pleasant little nooks and crannies.
Anyone that's ever refurbished a house, it's like that sort of weird black stuff that just seems to accumulate on everything. It's like, ugh.
Yeah, sometimes it's mold, sometimes it's just cobwebs and kind of dead woodlice husks of the ages, and it's not ideally what you want to be breathing in. And there are actual, those are actual contaminants too, but there are things like if you've got glass fibre or rock wool or whatever in your walls and then it's bringing little fibres of that, it's best not to be breathing them in permanently and plaster dust and all of that kind of thing, even before you get into the kind of potential harmful mould spores and things.
Yeah.
It also protects, this is another bit of ranting about airtightness, it also helps you have a long-lasting building, because any air that's drawn through these sort of nooks and crannies or little holes in your building will draw moisture with it. And where that meets a cold surface, that's going to condense. So you've got more chance of things rotting and decaying, basically, if you haven't got an airtight house or an airtight building.
Yeah.
Basically, just assume when I say house, I mean any kind of building. I sort of often default to houses. It is just a default, but it applies to absolutely any building.
Yes, because there are passive house. Would you still call it a passive house office?
Yes, it is confusing. I think I can't remember the exact literal translation of house in German, but it isn't.
It isn't what we say as house.
Right. Yeah, it's slightly different. So, but yeah, there are passive house schools, passive house offices, warehouses. I think there's definitely a couple of passive house archives that I'm aware of.
Well, that makes sense. Very controlled.
Yeah, absolutely. You can keep nice humidity and nice even temperature, and I think the systems installed in those will be slightly different to the systems in another building, but again, it is very individual to each building, and the system allows you. It's really just a calculation method that enables you to make sure your building is going to work, whatever the building is.
In terms of airtightness, how airtight are we talking? Like, are we? Because there's preconceived ideas that it's, I'm going to be living in a balloon.
Yes.
Is that fair?
No, I think it's in short. Moving on.
Next question.
It's true that seems to be a perception, but it's understandable where that idea comes from, but it doesn't really reflect the reality. The key thing, even if you've got a ventilation system built in, even if it turns off or there's a power cut, you're still not sealed in. The fact is those ducts are still permanently open to the outside world, so there will be some air movement through those anyway. And just like in any building, you can open the windows and doors, so there's a constant ability to get just as much ventilation as you would through opening windows in any building. Plus, you have the additional thing of the mechanical ventilation. So if anything, they're better ventilated and they're less of a bubble than another house. Although in an older house, he says, again, looking at his windows, there might be gaps between the windows and the walls. The windows might not seal properly, so you're less of a bubble in that sense, but you won't have better air quality. You won't have better ventilation. You'll have poorer quality ventilation.
Yeah.
And you absolutely can, and people frequently do, because they like to open windows. So you could always open windows, you can always open doors.
That's always the thing, isn't it? That's another of the things that people say when they go, oh no, I don't like passive house. I like to open my windows.
Yeah, and you should. You should open windows. It's always a good thing. You. People like that connection with outdoors, and it does give you a boost of ventilation when you need it. And it's built in to passive house. So if it's a certified passive house, and if it's been designed properly with PHBP, even if it isn't certified, you have to allow for cross ventilation through opening windows additionally. So it's sort of specified that you must check that there is the ability to have cross ventilation through opening of windows, partly in case there's a power cut or in case the ventilation system fails. Like I said, even if it doesn't seal you in, it's still open, but you might want more ventilation through windows at that point. Yeah. Or in summer, it can assist with cooling if you have really good cross ventilation, or if you're in a sort of 2 or more story building, if you open a window downstairs and a window upstairs at night particularly, that will give you a kind of chimney effect that the warm air will sort of drift out of the window at the upstairs and draw in cooler air behind. So all of that is built in. So but making sure that you do have, this is a very long-winded way of saying you have to have openable windows or it isn't really a passive house.
Fair enough. Good. There's a whole education thing that it confused me when I first started living in a straw bale house in America, and people didn't understand how to live in a well-insulated house. And, they'd leave all the doors and windows open during the day when it was hot. And then they go inside and go, oh, it's hot. This insulation doesn't work. And then it was only sort of, someone had to come in, and it was on a sort of education campus. And someone came in and said, oh, what you need to do, shut all your windows during the day, open them all at night.
Yeah.
And that's, you're trapping that cool air inside during the day, insulating from it. And then when it's cool at night, open your windows, flush out any extra heat.
Absolutely.
It's like, it's completely backwards to how an uninsulated house that I've lived in, all my life is.
Yeah. Because, again, using my current house, I do like my house, I should say. I'm going to be reading about it a lot in the course of this. But it's a really good example of how we would need to open windows during the day just because the roof is so badly insulated, and it's one of those sort of old, low Scottish cottages with a room in the roof with very low roofs, very low ceilings, and it's, sort of dark slate roof, so that absorbs a lot of sunlight, radiates it into the upstairs space because there's no insulation to stop that happening. So it gets really, really hot up there, and we have to open the windows. And unless it's really hot outside, it will always be hotter in the summer in those conditions inside than out. So opening the window still helps. But yes, if it was insulated like it should be, then that radiant heat wouldn't get in. And then, we probably would keep the windows closed more during the day and just open them at night to let sort of the cooler air come through and ventilate. So I guess there is a bit of kind of training people in a way to know how to use these sort of really efficient houses, because it might be different to what we're used to. But I think it's very doable. There's nothing major to kind of change. It's just making sure people understand what will be different, I guess, when they have a house like that. Because it isn't the norm and we're not used to it. It hopefully will become normal, ideally really soon.
Yeah.
It really needs to. I think it's happening, but still too slowly.
We'll be back after a quick break.
Hey there, I'm Mick from the Mick and Pat Show.
That's right, and I'm Pat.
Looking for a podcast that's like catching up with old friends? Well, you're in luck.
We're here to bring you weekly doses of lifestyle commentary, discuss culture and politics, and top it off with the occasional beer and film reviews.
But it's not just about us, we're a community. Our listeners are our kin, and we let you all have a say in what we discuss.
So saddle up and join the conversation at the Mick and Pat Show. You can check out our website or find us wherever you get your podcasts.
Yeah. I mean, do you think that, I think I saw something you shared on Twitter, which was like a proposal to make all new homes in Scotland Passivhaus or maybe something similar?
It was something along those lines. I'm struggling to remember the details of it myself now, but yes, it wasn't an official position, but it was a private member's bill or whatever the Scottish Parliament equivalent is. Someone very sensibly proposing that this should happen, that whatever exactly it was they were proposing, this is where it gets really vague. I think it was along the lines of all new buildings or should be built to Passivhaus standard.
Yeah. Which
would be amazing because that would immediately increase the number of passive houses being built. And that's the reason I think that's a really good and important idea, is because they're so energy efficient and potentially, if they're designed well and if you have sensible use of materials, the sort of whole life carbon emissions of a passive house will be lower than an equivalent house built to a slightly lower standard, even if you've had to use slightly more glazing, or not glazing, but like triple glazing rather than double glazing, and slightly more insulation in some places. The carbon calculation still works out that it's lower carbon over the lifespan of that building. That was a calculation I did a few months or so ago, I think, looking at exactly that. So taking a building that met building regs and then increasing the specification of it, so a bit more insulation, upgrading the windows, putting in an MVHR heat recovery ventilation unit
in a retrofit way, or in a just upgrading it.
This is just a sort of theoretical exercise. So it was a theoretical new building regs house, and then tweaking the specification of that to make that meet Passivhaus without changing the design. So it's sort of a worst case scenario in terms of the carbon impact, because in reality what you would do is you'd look at it and go, well, actually, if you just tweak the form of that slightly, or you rearrange the windows slightly, then it will perform a lot better and you won't need more insulation, sort of thing. Because that's often, I'm jumping ahead, I'll stick to that one for now. So looking at this comparison of the building regs and the Passivhaus, which I should say was based on work for the Passivhaus Association of Ireland, and then this work was part of some work for the AECB and the Passivhaus Trust. So it was all sort of motivated by them. I can't really take credit for it. I was just happily involved in some of the calculations. But normally you wouldn't just upgrade the specification to get it to beat Passivhaus. You would tweak things. So I think in terms of carbon, it's a slightly worst case scenario, because it does involve more insulation than you would necessarily need. And even in that scenario, the Passivhaus design came in over a sort of reference 60-year lifespan as lower carbon, including the embodied carbon of building the thing and all the things that go into it, and the ventilation unit, and the operational carbon, so carbon from heating it over its lifespan. That was lower for the Passivhaus option than the building regs option. So there's sometimes another perception that, yes, you'll save energy, but you'll need to use a lot more energy to produce the things. And that certainly can be true, depending on how you design your house or what materials you use. But it doesn't have to be true, and it most often isn't, I think. So most often the whole life carbon will be lower for a Passivhaus than for a less well-spec'd, slightly more poorly built building regulations compliant house.
Was it sort of significant, or?
The building regs house came to, over its lifespan, 19.5 tons of carbon emissions, including that, the embodied carbon and the operational carbon. The Passivhaus came to 16.8. So I guess what's that? 3-ish tons, he says, showing how bad his mental arithmetic is.
Do you only work numbers with spreadsheets?
Primarily. So that's 2.8 tons difference, which isn't massive, but it is a difference.
And you're saying that that's not the ideal designed house. That's just...
If in an ideal world, you would look at the sort of starting baseline house and go, actually, we're going to tweak the design of this. We're going to manage to do it with less materials, less extra bits and pieces, and potentially save materials and crucially save money. This is the point I started to come to earlier, and then tried to stop myself going on a tangent, is that you can often, through the design process of making the building work better, you can also save the client money, which is usually a helpful thing. Mm-hmm. And you're saving money through usually using less resources. So you get that kind of dual positive bonus, I think, which this sort of technical exercise, he says, pointing at the screen, which nobody can see because it's all audio. But the building regs Passivhaus comparison didn't do, because it was just looking the exact same form, exact same size windows in exactly the same places, sort of thing. Yeah. So even in that case, it still saves energy and carbon over the lifespan. But crucially, there are a whole bunch of other benefits for anyone that would be living in that Passivhaus, in that they will have just greatly improved levels of thermal comfort. They won't have the cold drafts. It will feel a comfortable temperature all the time. They'll have really good air quality, and they'll have massively reduced running costs. So there's brilliantly an increasing amount of Passivhaus social housing, which feels to me like the perfect combination of things, because it means instead of having like a lot of older social housing where frankly the conditions aren't that good.
They're inhumane sometimes.
Yes, exactly. I was trying to sort of
I can say
be more diplomatic, but
yeah,
some of it's awful. Some of it's absolutely awful. And you can build massively high quality housing essentially with, again, all the comfort, indoor air quality benefits, and really low running costs, which is ideal for social housing, where people
that really need low
it's a way of tackling fuel poverty essentially.
Yeah. And it's been a source of great frustration for me that as a builder building these homes, I often end up building for mega rich people, and in my ideal, I'd be building social housing, and the people that need it would get it.
Yeah,
and I think it's kind of, though, we're at the pointy end of the wedge, and it's the people that can afford that sort of new thing that are going to set the sort of trend, I guess.
Yeah, and I think there's a sort of, there's been now quite a lot of development of different methods and kit and ways of putting things together to make passive house or similar levels of energy efficiency work that can now be sort of, have been being rolled out for a while now. So that I think that sort of starting on smaller projects, it helps develop things basically, and that's moved on. Or it has moved on. I'm still mostly doing sort of similar to what you say, working with people who can afford to build their own houses, and but there are thankfully other people who are doing the social housing side of it, so that's great. And I'm getting more experience doing these sort of smaller projects. If I was, I don't think I could cope straight away, frankly, tackling a sort of big housing block full of social housing, because I haven't got the experience yet. So on a personal level, it's sort of the right way to start, and then building up from there, hopefully.
That sounds great. Yeah, it's your sort of I don't want to say apprenticeship, maybe. It's the wealthy are sort of paying for your education.
I wouldn't tell them
great.
That, but
no.
Although with many of them listen to this, but yeah, essentially that's what's happening. I get to learn things through other people's projects.
Yeah, I've felt that about every project I've ever built. It's like, I just got paid to learn a whole load of stuff, whether it was through like tragic consequences where I never want to go back to. It's all learning.
It is all learning. Learning is not necessarily fun.
No.
Often it is, but yeah. It's quite reassuring actually, following sort of quite a lot of more experienced passive house people on Twitter, that even sort of people who I kind of think know everything, every now and again will just ask a question about how to do some obscure thing that they haven't had to before, and that's quite nice, because I do that quite a lot. So it's nice when more experienced people at least do it occasionally. Yeah,
and it does seem like there's a good community. I mean, I've seen multiple people sort of asking those sort of questions.
Yeah, it's
people seem to be willing to chip in, and there's a sort of strive for that like communal good and communal knowledge, as opposed to like trying to hold it close and like that's my knowledge.
Definitely, and I think it is because mostly the people who get involved in, I can say passive house, but also just any low carbon, low energy building, are doing it because they think it's what needs to happen. And if you then keep all that information to yourself, you're not helping it happen, except in a really small way. So I think there is a general sense of the kind of need to make it better for everybody. That sounds really worthy, and I don't mean it in that kind of worthy way, but just I think that is the motivation factor, and it's people want to share information because they want other people to be doing it. There's not that sort of level of competitiveness that it's like, well, I can't tell them that because then they'll start doing things that I'm doing. I think there's also still not enough of us doing it. There's thankfully, I think, a rapidly increasing number of people training to do passive house, and I think the rate of increase is increasing as well.
Mm-hmm.
Or that's the sense I have. But there's still not enough of us. We don't need to worry about kind of competition in that respect. I think there's more than enough work to go round. So and anyway, people just want to share the information, and I think we all enjoy those geeky conversations that result as well, frankly. So there's definitely a side of that. And it's like sometimes I have this sort of slightly ridiculous, almost advertising slogan in my head that I would never use as an advertising slogan, but it's kind of like, I geek out so that you don't have to. That's kind of my purpose, is I do the geeking and then try and translate it into sort of straightforward non-geeky language so that the people who actually just want to know what they need to do can know what they need to do.
Oh, you're the conduit of geek.
Oh, I want that on a headed notepaper. John Butler, conduit of geek. I'm going to put that on my Twitter profile.
Well, I mean, so I've got a few questions in there. Do you know roughly what sort of quantity of passive houses are being built? Are we talking 10 a year? Are we talking 100 a year?
I don't know. I should. It's one of those things that I have been asked before, and I go, I will look that up, and then I've got busy doing other things, and I haven't looked it up. The Passivhaus Trust will almost certainly know.
All right. Well, I will go and look that up.
Yeah, go and look that up.
I'll put it in the show notes. Yeah.
Yeah. The Passivhaus Trust are like the UK body that represents Passivhaus buildings and do research and promote Passivhaus and support Passivhaus designers and consultants.
Yeah.
And they're a great resource. They've got loads of information on their website in mostly quite clear, understandable language, which is brilliant. The Passivhaus Institute, which is the German body that sort of operates Passivhaus, also have loads and loads of information on their website, but potentially in less of an easily digestible form, I would say.
Yeah, understood.
But they're where we go and kind of get the sort of crucial geeky updates and things that we need.
Because it's a standard, isn't it? That's sort of run and by the Passivhaus Institute. And it's sort of a thing that you can accredit to, like, the Living Building Challenge or, other building standards.
Yes, that's crucial information that I've failed to talk about. Yes, so that's
why I'm here.
Exactly. Get me back on track. So yeah, that kind of comes back to the ages ago, the question about sort of, in summary, what is Passivhaus? I've told you what you need to do to achieve it, but not what it is you're trying to achieve, in a sense. So the really well insulated building, the good ventilation and the good airtightness are all about, they're all about making a comfortable, energy efficient building, but that's quantified by sort of key criteria. So there's a heating demand target of 15 kilowatt hours per meter square per year. So for every meter square of internal usable floor area, it's probably the simplest way of putting it. So all the floor area that you can move around on or put tables on that isn't taken up by walls or stairs or that kind of thing. So it's 15 kilowatt hours per meter square of that per year in heating demand. So that should be how much heating energy you need. Or there's a peak heating load target of 10 watts per meter square. And that's the same usable floor area that your meter squared applies to. And that's looking at basically your peak heating output on the kind of most challenging day in the winter. And that looks at, this is where I need to check my internal explanations of things. It's basically looking at two alternatively challenging winter days, one of which is really cold but sunny. So although the outside temperatures are cold, you might get a reasonable amount of solar gain. The other is perhaps slightly warmer but overcast, so you might have slightly higher external temperatures but less solar gain, and essentially assesses which of those is worst for your particular location and your building. So that will be affected by how much glazing you have and which way it's facing and all of that kind of thing. And it uses that to calculate your peak heating load. So that's kind of your, I guess that's what your boiler sizing comes from, in a sense, or your heat pump sizing comes from, is what's the biggest output you'll need potentially, what's the worst case scenario that you have to meet, and that's the 10 watts per meter squared. And you can certify your Passivhaus if you meet either of those, which makes it a bit flexible. There's some discussion around whether using the peak heating load target is better, because essentially if you meet that target, you're probably relying less on solar gains to balance the heating demand, and you've just built an efficient envelope where you need less heating demand in the first place. Sometimes you can end up, if you're looking for the 15 kilowatt hours heating demand target, you could potentially meet that just by putting in more windows. in the right
Right.
place to kind of maximize the solar gain, but that causes
So you
other
can
problems.
sort of cheat it a little bit.
You can almost cheat it, but then what happens is you increase the overheating risk usually, and you increase the kind of daily, I'm waving my hands around in a way which is again really unhelpful, because audio, it's
John conducts the conversation.
yes, John conducts the daily stroke of temperature in your house. So the bigger the difference between your maximum and minimum internal temperatures, essentially that's an overheating risk indicator. So if you can, and it's less comfortable. If you can keep a nice even temperature, that's really comfortable. And that tends to happen more when you design to the peak heating load target rather than the heating demand target. But there's sort of some discussion about that, and I'm still very much learning about that myself.
Yeah.
The other key target is the air tightness that we discussed. And you asked me ages ago, I've just remembered, and I didn't really come back to it, which is how airtight is that, I think.
Yeah.
And there is a number. It's been quantified by the Passivhaus Institute as 0.6 air changes per hour at test pressure. So when you do your kind of blower door test of sealing up vents and putting the giant fan in, or in a passive house, potentially not a giant fan, but a fan in the doorway, and pressurizing and depressurizing at 50 pascals difference to external atmosphere, the entire volume of air in the building is changed 0.6 times per hour. So at test pressure, your air is changed 0.6 times. And that's the maximum.
So I don't really understand how much pressure 50 pascals is.
It's not a massive amount, but it's like I don't know quite what that relates to in terms of kind of windy days. Probably a very windy day, I would guess, or a substantially windy day.
Yeah, I suppose it has to, doesn't it? Because it's the point of it is to replicate a very windy day.
There have been cases where during air tests, because the passive house where you do it pressurized and depressurized, and sometimes when you're depressurizing, if you have a sort of air tightness membrane somewhere that isn't sealed, that isn't fixed so well. Because for this test, you do actually seal everything up. So it's not like the normal living conditions where there's air movement through the ventilation. Yeah. You seal up the ventilation system. So then when you depressurize, sometimes membranes aren't fixed properly, will kind of pop off and come down. So it's a reasonable amount of pressure or depressurization, enough to cause that kind of thing to happen, and enough to cause membranes to kind of balloon out. But that's the only time you could call it a balloon, because in operation, it wouldn't be sealed up like that, because you'd have the ventilation ducts open, crucially. But so, yeah, over an hour, 60% of the volume of air in your house will have changed under that pressure, I suppose is what it actually means.
As a
maximum, yes. And quite increasingly commonly now, experienced builders who've built sort of a number of passive houses and with well-designed detailing by their architects or passive house consultants. Brief plug. Yeah, exactly. Me too. Again, in kind of 0.1. I'm trying to remember. I think there've been some even lower. There's been some incredibly ridiculously low ones lately. So it's just people are getting better and better at doing it, basically. And often that's about simplifying things so that there's less that can go wrong.
The details, which are tricky.
Yeah.
I'm doing the air tightness on my house at the minute, and it's the first time I've fully done like a whole membrane system, because normally I'm working with plaster and things that don't work in a house on a trailer. But there's details in there where I'm like, this is terrible. If I was designing this again, I would not have that meeting that. Yeah. And
it is, a lot of it is about kind of trying to plan ahead and designing things so that they fit together as simply as possible and make it as easy as possible to seal things together, and thinking about where services come into the building so that you don't kind of have a service duct coming up right next to an internal wall where it's really difficult to kind of get a gasket or a bit of tape around it. Just move it into the room a bit so that you can get at it, kind of thing. And it's none of it is that complicated. I think this is kind of my takeaway thing with Passive House is there's a lot of sort of jiggling around with numbers when you're putting it all into the spreadsheet, but really the things that make it work are pretty straightforward and simple, and often the more you simplify them, the better they work. And that's what's happening with people getting sort of increasing amounts of air tightness. It's the sort of comparison with, say, building regs, again, sort of particularly English building regs, because those are the ones I'm still most familiar with. I think there are similar targets in Scotland and Wales. Is the maximum you're allowed is 10. This is the frustrating thing. There are two ways of measuring air tightness, and building regs uses one, and Passivhaus mostly uses the other. They roughly end up being the same, but not necessarily. But the building regs way is cubic meters of air movement at the same air test pressure per meter square of building envelope. So it's a much more, it's a harder one to picture. I think air changes per hour is sort of easier because it's a simpler thing in a way. Not easier, but easier to get your head around, because you can go, there's this volume of air, this much of it is changing.
Yeah.
With the cubic meters of air per meter square per hour, it's how can I explain this simply? I'm now going, I've got myself into this corner that I've got to explain it.
Come on, you're the geek conjurer.
It's basically brilliant.
You can do this.
I can't. That's having just said it's all very simple. It's so simple I can't explain it. So per meter square of external envelope, so walls, surface area of like walls, roof and floor, basically, per hour, it's how many cubic meters of air are changed through that.
Okay.
So it amounts to it sort of equates to the amount of holes in your building fabric, and there is a really handy way of translating one to the other, and I've forgotten what it is. But there's a useful way of kind of estimating the size of hole that relates to, basically.
Right,
and I've completely forgotten what that is. But anyway,
I might know this.
Oh,
I don't. I think a passive house, a regular building to building regs would be a hole the size of a cash machine, and a passive house would be a hole the size of a credit card.
That sounds about the right scale of difference, definitely.
Yeah.
Yeah. I've heard, and you get ones where the hole is about a 20p piece because they're really efficient.
Yes.
But yeah, the building regs one is quite big. But regardless of
that's
the
a
two,
cash machine is a big thing.
The cash machine is a big thing. That's a massive hole. That's like having essentially your front door just open permanently.
Yeah.
Even when it isn't.
Yeah.
In terms of, that's what it comes down to, that it's controlling your ventilation. It's not removing ventilation. It's quite the opposite. It's just having control over where it happens and how it happens, which is how you get better air quality. But the cubic meters per hour per meter square and the air changes per hour don't match exactly, but they're often sort of fairly similar. Like the number for each will be similar-ish. And for building regs, it's 10 cubic meters per hour is the maximum allowable. Most builders, even sort of bulk house builders, probably get down to about 4 or 5, to be fair, but that's still rough. If you're talking the difference between 0.6 and 4 or 5, although they are slightly different metrics, sort of they're near enough for comparison's sake for this. That's however many fold difference that is. I was going to say 10, but it's not. It's more than that, isn't it? That 0.6 to 6 would be...
That would be 10.
It would be 10.
No, that would be 10.
Good. Yeah.
That's tenfold.
I'm really demonstrating my inability to do mental arithmetic here.
I mean, no volume house builder is testing their homes, are they?
Not.
Or do they have to?
They have to, but this is one thing which will hopefully change when the much delayed update to building regs in England happens. I think there's a similar one planned in Scotland, which is currently under consultation. I'm not sure what the situation is in Wales. I have to kind of... They're all slightly... They're broadly, over the whole of the UK, the building regs are very similar, but slightly different in different ways to catch you out, basically. But the current situation is that on a housing development, you don't have to test every house. You can test sort of one house out of however many. There is a slight penalty in the air test figure that you put into the ones you didn't test, I think is multiplied by something. I used to know this because this is all part of SAP assessment, which is your energy assessment for building regs, which I used to do. Kind of as a way to get more experience in dealing with buildings and things before learning about Passivhaus. And I've happily just this year stopped doing it altogether because it was so frustrating, because the gap between what needs to happen and what building reg says should happen is huge, and the SAP process is full of inefficiencies. But that's a whole other rant that we probably stay away from. Not inefficiencies, inaccuracies. But yeah, so you don't have to test every dwelling. It's supposed to be changing that you will have to test every building, and I think that's a much better situation, because what can happen is, in theory, you don't know which house is going to be tested, so it should be
tested
random.
by someone out external.
Yeah.
Okay.
But they can kind of lead you to testing a specific building. If you can say, well, basically, these ones aren't finished yet, this one is finished, so test this one. And then there's no real guarantee that the others are anywhere close to it. There's a slight penalty that you get when you put it into the energy assessment, but it could be that actually the reality in those other ones is even worse. And you can kind of have, people running around with mastic guns, sealing up any little holes as the test is done to make it fit the target, meet the target, which would be great if things like sort of silicon sealant made a lasting air seal, and they don't, because they shrink over time and degrade over time, and then it will start leaking again. This is the things that you would use to make a passive house airtight are proven and tested to be really long lasting, so that your airtightness shouldn't degrade over time, or if it does, it will degrade over a very long time. There's been a lot of retesting, I think, recently on some of the first passive houses in Darmstadt, if I remember right. I might be remembering wrong. There'll be people listening to this who know this a lot better than me. But yeah, the very first passive houses have been re-air tested, and there's been no change in the airtightness over that time. And that's, things have improved a lot since then. So even the first ones are still working, and things like the ventilation ducts, they looked at how clean they were and whether they needed cleaning, and found that they didn't, basically, which is brilliant. And it's again, just sensible design that works and is long lasting. Robust is a word I use a lot, and I haven't in this interview, but it's about building in robustness so that things keep working.
Very much on that. I mean, I think volume homes are built with such a short lifespan in mind that I wonder how that would change if they were suddenly forced to build passive house, whether they'd sort of apply that same, just get it built. I
think whether they were certified or not would become really important at that point, because generally I think you can build a non-certified passive house, and provided it really does meet the airtightness tests and the kind of the energy demand targets, it's probably still okay to call it a passive house. If it doesn't meet those targets, and if it doesn't meet the air test, and if it hasn't been designed in PHPP, you can't call it a passive house, or you shouldn't, because it isn't, basically. But I think if bulk house builders start building to passive house, possibly there would be more need for them to be certified to make sure that they are meeting all of those things. And it is, even without going to passive house, I think just having every single building air tested will be a brilliant quality control thing, because it does highlight, essentially, the better put together a house is, the more likely it is to meet airtightness targets, whatever the target is. So actually testing that is a really good way of highlighting good or poor quality construction. So I really hope, if nothing else changes in the next building regs, that coming in will make a big difference. I really hope it does. I hope other things improve too, but that one alone can potentially make a big difference. But with the building houses at the moment that will need retrofitting in sort of 10 to 15 years in terms of getting to the level of energy efficiency we need to meet the carbon reductions that we've got to avoid kind of runaway climate change, or it is already probably runaway, but to prevent the most catastrophic changes to our climate, we've got to use less energy, basically. Even as we decarbonise the grid, it's really important to still reduce the amount of energy we use, because essentially, like, decarbonising heating mostly involves using things like heat pumps, or, it involves electrifying heating, and then there's electrification of cars and all of that, all of which basically means we'll be using definitely more electricity than we're currently using. So if we're not reducing energy demand as well as decarbonising, we won't be able to do it, essentially. So it's, much as I talk a lot about carbon, it's really important to just reduce the amount of energy as you decarbonise as well. And this is where sort of passive house and retrofit are really important, because they're a big part of doing that. Buildings aren't the only thing that we're using lots of energy in, but they're a big proportion of it. 80% of the buildings that currently exist will still be around in 2050. So that's why retrofit is really important. And I think it's around 40% of European emissions are from in construction.
I think it's global.
Is that a global one?
Emissions? Yeah, from the built environment. I mean, that does include, the monstrous motorway concrete flyovers and, it's not just houses or buildings. So I think my final question on Passive House is like talking about, if all houses in Scotland were being built to Passive House standard, do you think that everyday folk can effectively use a passive house? And I may be being swayed at the moment because we're at that like pointy end of the wedge, and it's mostly the geeks that are building their own homes, and they're like, all into the, running the systems and getting it on their phone and monitoring. But give any random person on the street, a passive house. Like, there's a lot of education into how to use it effectively and, to get those energy savings. Do you think that it's a thing that everyone could do? And, is it within the sort of realms of expectation?
I think it is. I mean, basically. So yes, is the very short answer. But again, I think it sort of relates to that robust thing, and robust design should also include making things that people can actually use so that the building will work. And there's a bit of education to do, particularly with things like ventilation systems, so that people know what they need to do with them. But also the kind of robust design approach would be design a system that they don't need to do anything to, essentially, or need to do very little to. So you can have really complicated controllers that will change things, and you can put it on boost, or you could just set it up so that it runs constantly and just looks after itself. And there's, maybe that's sort of something that needs tailoring to who's using the building and how much they want to be involved, but it can be set up to just sort of primarily carry on in the background. And little things like, if you have a controller, putting it accessibly, potentially like near the front door or whichever door people go in and out of the house more, because you can potentially turn down your ventilation system when you're out of the house, so it's using less energy but just keeps enough air moving to prevent kind of condensation buildup. And if that's by your front door, or you're more likely to do it, basically, because you'll see it and you'll press the button on the way out, and you'll come back in and you'll press the button again. Or you can just set it up to keep running, and it will still use less energy than a non-passive house, basically. So there are decisions to make in the design that will make it easier for people to use, and then there probably is a little bit of education. And like you were saying earlier about things like realizing that when it's really hot in a well-insulated house, you probably want to close the windows to keep the heat out, because you've got the ventilation still happening. And this is another advantage of having that ability to control it. You can close the windows and still have ventilation. And so a bit of education and a bit of just designing so that less education is needed, in a way. Try and design things that will just work, which is usually about simplifying, I think, particularly with controls and things, and not having too many sensors of things that can go wrong or fail as well, because you can operate ventilation systems with CO2 sensors and humidity sensors, and that can potentially make them a very efficient system, but also it's more that can go wrong. And there will be circumstances where you probably need that. And I guess, I don't know, but I guess in things like the archives, where it's got to be very carefully monitored, and perhaps in schools and things where you want more of a sort of, you need to make sure you're keeping CO2 concentrations down so that people can concentrate. And that now tends to be not reflected, but with COVID and things, the need to have much more ventilation to reduce that risk. So sensors and that kind of situation probably make more sense. In kind of domestic houses, having really complicated systems with lots of sensors is just unnecessary, and it's more that can go wrong or be I was going to say interfered with, but that's that's not good.
Yeah, like a sensor could get painted over.
Yeah, exactly, accidentally. And if you don't know how something works, or if you just perceive that this ventilation thing is just costing you money to run, then you might turn it off without realizing that it's recovering more energy than you're spending on it, and actually it will be saving you money. So there is a bit of education, but just designing things that are simple enough to not need that much input. One thing with ventilation systems or heat recovery ventilation is there are filters in it, which is good because it improves your air quality again, but they do need changing sort of 2 to 3 times a year, I guess. So people need to be aware of that, but it's probably, and there's a bit of a cost in that, but it's probably sort of probably is less than you would spend on having your boiler serviced or repaired and that kind of thing.
Yeah.
And they go wrong a lot less because there's less to go wrong. Again, it's a simple system. There's a heat recovery, a domestic heat recovery unit just has 2 fans, which basically spin all the time at a low rate, and that's it. The rest of it is just ducting.
They're like sort of computer fans, aren't they? They're not like super massive.
Yeah, you're talking sort of 60 watts for a biggish unit, I think. And the rest of it is just the heat exchanger, which is just lots of little channels of air going over each other. There's nothing mechanical to go wrong, and ducting. So they're really simple in that respect. Sort of, this is like people sort of think of passive house things, we're going, oh, there's all this science, and there's a lot of science gone into developing it because it is physics based, which is why it works, because it's just the way heat flow and heat gain
because science
works. Because science. I'm trying really hard not to go because science, but yes, because science. But the actual things that you use to achieve that are so simple. It's not this kind of weird sort of mythical thing. It's just sensible, practical steps.
Yeah. Cool. Well, I've just spec'd my my heat recovery for my house because I'm making it as airtight as possible, and I've gone for, because I don't have any place for ducting, I've gone for 2 of the decentralized units that look like a bathroom fan, and to all intents and purposes, they are doing that purpose. But these ones, they work in a pair, and one will blow in and one will blow out, and heat up a sort of ceramic, looks like a honeycomb, and then they switch, and all the air that comes in is heated up by the honeycomb, and so you're capturing, I think they reckon, about 80% efficient.
Brilliant.
And they seem to be, I don't know, I mean, I get the impression that in the passive house sort of world, those are, I mean, they're not the go-to choice. Like a full system would be much better. But I mean, my house is only 6 meters by 2.5 meters. It's
it's proportionate. It's a proportionate response to your house.
Yes.
For a bigger building, you would probably want sort of something different. I think the kind of efficiency of the passive house units is, it tends to be sort of 80 to 90%, and that's the heat recovery efficiency of the whole system. So the measured heat recovery of the actual unit itself might be sort of 90%, 95%, but the sort of overall efficiency takes into account the lengths of the ducts that connect it to the outside world, basically, and how well insulated those are, because they're full of cold air essentially between the unit and the outside, and so you have to insulate those. So if those are shorter, it's more efficient. But yeah, the overall efficiency of the system should be sort of usually around 80 to 90%. So 80 to 90% of the heat that is extracted from your house is put back in again. So you only need sort of a tiny bit of top-up heating to stop the temperature dropping over time, basically.
I mean, it all sounds, I have to admit, I've been a little bit wary of passive house. I've felt, and I think it comes from a place of the seeing all of the big foam and concrete houses being built in the name of sustainability, and feeling like I was very anti that, sort of we're going for the same thing, but in a different route. I was always looking at natural materials, which I'm going to come on to next because you've given
Nice
me
segue.
a whole life complex. The more I learn, it's with most things, isn't it? You're a bit anti the things you don't really understand until you actually understand them. You go, oh, it's actually really good.
I think I've probably had a similar journey with it because, this is the thing about Passivhaus Standard is you can build it with anything that will enable you to meet the targets, which can mean lots of concrete. It can mean lots of PIR foam or that kind of thing. Or you can build it with much sort of what you might call more friendly materials, lower carbon materials and more sustainable materials, and still hit those targets. And that's obviously where I'm at. And thankfully, where quite a lot of other people are at with Passivhaus. It's probably, there's a bit of a bubble in that the people I communicate with and follow, that's what they're doing. The people who are building the kind of really concretey, foamy ones, I'm less involved with. So it is still happening, and I'm aware that it's still happening, but certainly my sense is there's an increasing number of people who are aware of the need to reduce both the carbon and energy emitted through making your building and the operational carbon and energy. And I think the Passivhaus Institute themselves are catching up with that now. And I'm not like, this is where I'm going to get really vague again. They've been looking at embodied energy and whether and how to integrate that into the Passivhaus planning package. I can't remember whether the next version has that integrated or if it's still in development, but they're starting to look at it. And their take is very much looking at embodied energy rather than embodied carbon, which is, the two are obviously currently very closely related, but again, coming back to that need to reduce energy even as we decarbonize, I think if they stick with energy, then they can just stick with that and it will still be relevant. Whereas in a way, the sort of current focus is on reducing carbon because that's the urgent need. But at some point, we're going to have to stop looking at carbon and just look at embodied energy, I think, because things will have decarbonized, or the energy generation will have decarbonized enough that just the embodied energy becomes an issue rather than embodied carbon. So I think they're sort of preempting that and coming up with a system that enables it to stay the same, essentially, which is quite sensible. And also the whole Passivhaus thing is about energy targets, so it sort of fits within that. So they are looking at it. Sometimes people have criticised the standard because it doesn't look at carbon and that side of things. But in a way, I don't think you need a single standard that covers everything. You can use Passivhaus and just use it sensibly, essentially, but it's not prescribed how you build it, which is in some ways a positive thing because it makes it really flexible.
Yes, you have to be careful of over constraining. I always thought that with sort of straw bale details. I was always really wary of putting out in my work with SBUK. It's like putting out like these are the ways to build a straw bale wall, because then someone came out and built like this beautiful arched straw bale building. And it's like, well, that doesn't use any of those systems. So if we say this is the way, then that doesn't exist. So, don't over constrain. But yeah, I did just see on LinkedIn, it was just a couple of days ago, someone saying how happy they were that they had managed to, the client wanted their Passivhaus to have a basement and concrete floors on the ground floor. And they were showing their massive I-joists with concrete between them and congratulate and like saying, look at this great thing I've done. And I thought about kind of getting into an argument online. And then I remembered that there was better things to do. But yeah, I just kind of put my head in my hands a little bit.
Yeah, it is still happening like that. But I think the more, it's that thing, the more we keep plugging away at it, but then I kind of swing between thinking like that and then going, but we need to change now because we do. But things are changing, and hopefully the rate of change will escalate because otherwise we are in trouble, he says optimistically. I'm sort of optimistic. I'm saying that the rate of change will escalate. So.
Yeah. Yeah, it's sort of like saying that maybe one day soon we'll stop thinking about maybe perhaps using fossil fuels. Oh no, we're not allowed to say fossil fuels. In the sort of COP statement of nothingness. Yeah. Anyway.
I've got, I'm in two minds about that as well. There's part of me just going, clearly this has not gone far enough, and partly going, yes, but it is still a massive improvement on any statements they've made before, of just the fact that it does mention fossil fuels. I can't believe it. I only found out in the last year that fossil fuels have actually never been mentioned in a COP statement before, which is insane.
Someone on the radio said it's a bit like talking about the obesity crisis without mentioning food.
Yes, nice analogy. Yeah, but so at least they're mentioning it now, which is that shouldn't be a massive step, but is. Yeah. So I've got such mixed views about the outcomes of COP in this. I think I'm trying to be optimistic and think, yes, it doesn't go far enough, but at least it lays the ground for them to hopefully go a lot further quite quickly. I think
COP27 will be the one.
Yeah, or there's meant to be a sort of update of countries' targets for carbon reduction next year, I think. So I'm if that is a complete letdown, then I'll be miserable. But until then, I'm going to hold on to optimism that maybe they'll pull something out of the bag then.
Good.
Fingers crossed.
Yeah, I mean, I'm happy for you. I wish I could.
I'm aware that it might just be my own little private bubble, but at least I'm going to hold on to some optimism for a little bit longer, because it enables me to function. I think this is that balance between kind of terrifying people and getting enough optimism that people don't give up, because I have had some people sort of basically going, what's the point in even trying? And it's a really difficult question to answer, because I feel very strongly that we have to try. But some people have that sense of despair, essentially, so strongly that it's really difficult to kind of logically reason with. And I don't know what the answer is to that. I would love to have a better one. But I think having some optimism is useful for actually continuing to try making a difference and to make differences which will add up. I think if we all kind of just fall into a pit of despair and don't do anything, then definitely things will get very bad very quickly. Whereas if we keep changing things, then they'll still get worse, but they won't get as badly worse. There's a much better way of saying that sentence, but I can't think what it is right now. But
I get you.
So some optimism is necessary. Shorter version.
Thank you, John. That was brilliant. I haven't chuckled so much at some good geekery in a long time. So thank you once again. I wanted to say, just to follow up on a few of those points that were unanswered during the episode. The Brian Eno cards were called Oblique Strategies. They were a set of 100 cards which had a suggestion or a course of action or a thinking to assist in creative situations. Some examples of what the cards say were: what would your closest friend do? What to increase? What to reduce? Or are there sections? Consider transitions. What else? Oh yes, so I've looked up passive houses per year. It looks like in the UK there are about 200 a year being built. There's a couple of links to that in the show notes. I think that's about it. As I said at the beginning, there is another episode with John coming next week on more natural materials, and you can hear how John just gave me a complete crisis of identity. So that's it for this week. Sorry it's so rushed. I just wanted to squeeze it all in. If you have enjoyed this, then please do subscribe if you haven't already, and share the podcast on all your social medias. It really does help to get the podcast to more ears. Become a patron if you really like it. Thanks. I really like you listening. I hope you're having a wonderful day, and see you next week. Bye bye.